Now that we've learned about the factor theorem, we're going to be applying the factor theorem and division of polynomials to solving polynomial equations. So here, as you can see, we have an equation. We're going to first simplify this equation before we solve it. Now for this equation, we're going to make sure we move everything to one side. So we're going to have 2x cubed plus 3x squared minus 11x minus 6. This is equal to 0. Now that we've moved everything to one side, the first thing we're going to do is find a factor of this equation. Now, as we saw in the last few lessons, we can apply the factor theorem. So we're looking for which value of a is going to make our equation equal 0. Now we're going to use -6. So numbers that go into -6 are plus and minus 1, plus or minus 2, plus or minus 3. So I suggest you start with plus or minus 1, and then from there we're going to see what we sub in for x is going to make this equation equal to 0. So the number that we get, f at 2, will equal 0. So that means that x minus 2 is a factor. Now, we've been using a mix of long division and synthetic division. You should have the hang of long division now. So we're going to use synthetic division for this question, but you can use whatever you're comfortable with. So we are going to check. So if f at 2 equals 0 and x minus 2 is a factor, we're going to use positive 2 on the outside. And then our coefficients are 2, 3, -11, and -6. So we're going to work our way through. So we bring down the 2, multiply, we get 4, add, and we get 7. Multiply, we get 14, add, and we get 3. Multiply, 6, add, and we get 0. So because this equation is in the third degree, when we write our answer here, we're going to have it start with the second degree. So 2x squared plus 7x plus 3, and we have a remainder of 0. So now we have x minus 2, and we have 2x squared plus 7x plus 3. Now, as you can see, we can factor this trinomial. So I'll give you a moment to factor. So we end up with x minus 2, 2x plus 1, x plus 3, and that equals 0. So we're not done yet. We're asked to solve. So we need to state the values of x. So we're going to have x is equal to 2. And then here, 2x plus 1 equals 0. So if we divide both sides by 2, x is equal to -1/2, as well as x is equal to -3. Okay, so those are our 3 factors. So therefore we have x minus 2 multiplied by 2x plus 1 multiplied by x plus 3. And that would give us 2x cubed plus 3x squared minus 11x minus 6. Okay? So this time, what do you notice that is different in this equation? Well, we have the degree of 4 instead of the degree of 3 this time. So we're going to start off this question the same way. However, there is a bit more work to be done to break down this equation to find what the factors are. So first thing we're going to do, we're going to find which value will make this equation equal to 0. So we're going to check plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12 if we need to. And we'll see that f at 2 is going to give us 0. So we're going to take this equation and we're going to divide. So if f at 2 gives us 0, so we have 2, and then we're going to take the coefficients. So we have 2, 5, negative 5, 20, and negative 12. Just a reminder, make sure that we have all the degrees, 4, 3, 2, 1, and our coefficient. If one of these was missing, we would still have to write it in our ladder, but we would write it as a 0. So for instance, if we did not have 5x cubed, we would replace this with a 0, okay? Okay, so let's solve. So we bring this down. We have 2, we're going to multiply 4, add, and we get 9. Multiply 18, add, we get 13. Multiply 26, and then we add, sorry, this is negative 20, add, and then we're going to get 6. And then multiply 12, add, and we get 0. So because our question is to the 4th degree, we are now going to write this equation to the 3rd degree. So we have 2x cubed plus 9x squared plus 13x plus 6 is equal to, we can call this h at x. So now, to factor a polynomial to the 3rd degree, well, what do we have to do? We have to divide. So once again, we are going to find a factor of this equation. So we're going to look at 6. So you're going to check plus minus 1, plus minus 2, plus minus 3, plus minus 6, and you're going to see which value is going to give you 0 for your equation. So after we check, h at negative 1 gives us 0, which means in our ladder, what are we going to use? We're going to use negative 1 on the outside, and then we're going to use our coefficients. So we have 2, 9, 13, and 6. So 2, 9, 13, and 6. So we're going to bring this down. Multiply, we get negative 2. Add, we get 7. Multiply, we get negative 7. Add, and we get 6. Multiply, we get negative 6. Add, we get 0 as the remainder. So we just factored for a cubic function. So we have now 2x squared plus 7x plus 6. Is this factored fully? No, this is a trinomial, so we're going to factor this trinomial. So I'm going to give you a moment to factor this trinomial. You can pause the video. Okay, so now that we've factored 2x squared plus 7x plus 6, well, what are we left with? We're left with 2x plus 3, x plus 2. So when we're asked to solve this equation, our final answer, we have to look at all the factors. So the first factor we looked at, f at 2 equals 0. So we're going to have x minus 2. The next factor that we used, we saw that h at -1 equals 0. So we're going to have x plus 1. And then we factored our trinomial. So we have 2x plus 3 and x plus 2. So now we have fully factored our equation. If I were to expand and simplify this, I would end up with our question. Okay, so if I were to expand and simplify this, I would end up with 2x to the power 4 plus 5x cubed minus 5x squared minus 20x minus 12. Okay, so let's take a look at this in Desmos. So our original equation, we have 2x to the power 4 plus 5x to the power of 3 minus 5x squared minus 20x minus 12. So if we take a look here, as you can see, we have our x-intercepts that we found. You can also see that we start in quad 2, end up in quad 1, which makes sense because to the degree 4, we have a leading coefficient that is positive. We have a local minimum here. So what I'm going to do now, I'm going to take our fully factored equation and see if it's equivalent. So we had x minus 2, x plus 1, 2x plus 3, and finally x plus 2. So, do you see that they're equivalent? They are. So this helps us with seeing that we did factor correctly. Okay, so we are going to work on a word problem. So we have an open-topped box. So that means that if you look at this rectangular prism, there's no top to this box here. There's no top here. It's open. So we have an open-top box. It's made from a rectangular piece of cardboard. The dimensions of the piece of cardboard are 15 centimeters by 20 centimeters. And then we cut congruent, so congruent means the same, congruent squares from each corner, and then we fold up the sides. So let's just take a look at what this would look like from a 2D perspective. So if we have a rectangle here, what's going to happen is we're going to cut out these corners. Okay, so we're going to cut out these corners. And when we cut out these corners, we can fold the pieces up. So we're really folding along these lines here. Okay, so what happens is this becomes the base of the rectangle, this part here. And then when we fold up the sides, those corners that we cut out, they don't really exist. That's empty space. So these are going to end up being the sides. So this is the front and back. and then these are the sides. It's always a good idea to draw the diagram to help you get a visual. So we're told that the box has dimensions of 20 centimeters by 15 centimeters. Okay, that does include the part that we're cutting out. Now we're going to cut out congruent squares. We don't know the length of those squares, the dimensions. So what we can do for now is just label the dimensions of the squares as x by x. We can use x by x because we know that the length and width of a square are equal to each other. They're the same. Okay, so now it says determine the dimensions of the squares to be cut to create a box with the same volume of 378 centimeters cubed. So, back to basics. How do we find the volume of a rectangle? So when we're looking for the volume, we're going to use V equals length times width times height. And we're given that the volume here is equal to 378 centimeters cubed. So we have 378 equals to the length times the width times the height. So let's look at what the dimensions of this box are. So when we cut out the corners, what is the length going to be? It's not going to be 20 because we're cutting out x and x. So 378 would be equal to, our length is 20 minus 2x. What would our width be? So for the width, we're cutting out x and x. So our width, we would have 15 minus 2x. And finally, our height of the box is x, because we'll be folding up these sides. So that's the height. And that's equal to 378. So in order for us to find the dimensions, we need to know what x is. So we're going to actually solve this equation. So what we're going to do, we're going to expand and simplify this equation. So we'll have 378 equals, and then we can use FOIL here. So we're multiplying the first, outside, inside, and last terms. So we would have 300 minus 40x minus 30x plus 4x squared. That's being multiplied by x. So what are we left with? So we have 378 equals 4x cubed minus 70x plus 300x. So this is our equation. Now we're going to bring the 378 to the other side. So we're left with 0 equals 4x cubed minus 70x plus 300x minus 378. We now have an equation that we can work with. So we're going to apply the factor theorem. We're going to find a number that will make this equation equal 0 when we sub in x. Now, as you can see, we're looking for a number that goes into 378. This is why I've mentioned before, start with the smaller factors. Do not try and think of a large number that goes into 378. So what we're going to do, we can start with plus 1, minus 1. It's an even number, so 2 goes into it. We can check plus and minus 2, and then plus and minus 3. So I'll give you a moment to find those. So f at 3 gives us 0. So now we're going to check the factor for 3. So for our ladder, we're going to have 3. And then we're going to have 4, negative 70, 300, and negative 378. So we bring down the 4, multiply, and we get 12. And then we're going to add, and we get negative 58. Then we multiply 3 by negative 58. And what do we get? We get 174. And then negative, add, and we get 126. Then we multiply 126 by 3, we get 378, and then 0, which is our remainder. So this equation was to the degree of 3, so we're going to write 4x squared minus 58x plus 126. Now we need to factor this equation. So right now we have x minus 3 and 4x squared minus 58 plus 126. So I'll give you a moment to factor this. You can use quadratic formula. You can use whatever you like here. So I'm just going to do this on the side here. So if we use quadratic formula, our a value is 4, our b value is negative 58, and our c value is 126. So x equals negative 58 plus or minus the square root of negative 58 squared minus 4 times 126 divided by 2 times 4. So when we simplify this, we're going to get x equals 58 plus or minus 3,364 minus 2016 over 8. Which is 1,348. Okay, so we're going to simplify this. And we end up with x1 is 11.8. And x2 we get 2.7. Okay, so if we check these possible values, so far we have x can be 3, and then x can be 11.8, x can be 2.7. We need to make sure that this is possible. So if we were to solve the length and width, and we were subbing in these values for x, would we be able to sub in the values? So for sure, we wouldn't be able to sub in this value here, because if we sub in 11.8 and we subtract 11.8 on either side, what happens? It's greater than the length of the rectangle. So that doesn't make sense. Okay, if we were to sub in 2.7, would that work? So if we were to sub in 2.7, that would work as well. And if we were to sub in 3, that would work as well. So our options here, if we use 3 for x, and then 20 minus 2x, so we would do 20 minus 6, and we end up with 14. And then 15 minus 2x, we end up with 9. So let's see, volume would be 3 times 14 times 9. It gives us 378. So this is a possibility. Now let's check with 2.7. So x would be 2.7. 20 minus 2x would be 14.6. And 15 minus 2x would be 9.6. So the volume, 2.7 times 14.6 times 9.6. Does it work? Yes, it does. It's a little bit bigger because we didn't use exact values. So technically this is the correct answer, but you can use both. Okay, the reason why this is a little off is because we rounded some places. So these are the possible dimensions of this box.